Welcome to the Credmark Workshop brought to you by MetricsDAO. Credmark is a multi-chain on-chain data provider um, focusing on DeFi protocol modeling. It's a modeling framework built with a few great ideas to create data models for Web3. And in today's workshop, we will learn how to build and deploy different types of models. And today with us, we have Kun and Meet uh, from the Credmark team. And let's kick this off. And I will give the mic over to Winnie to present as Credmark.
Hey, thanks for the intro, Eda. Good morning, everyone. Welcome to this exciting workshop hosted by Credmark. Before we dive into the world of building powerful financial models, let's take a moment to understand the incredible resources at our disposal. I'm Vineet, Credmark CTO. I love to find hard problems and I code a lot. And joining me today is Kulun. He solves all our problems. He's a math maestro and will be your guide in this workshop. Today, we have the privilege of exploring the intersection of financial modeling and the groundbreaking technology provided by Credmark. So let's wake up, tune in, and embark on a journey that will equip you with the skills to create impactful models. But first, let's understand what Credmark is all about and the model framework it offers. Credmark has developed a cutting-edge model framework that leverages the power of Web3 nodes and ETL with custom datasets, we'll refer to that as later, into the world of DeFi. This framework serves as the backbone of our workshop, empowering us to build robust models that can transform financial analysis and decision making. Today, we will explore the fundamentals of building models using our model framework. We'll cover everything from the basics like querying ERC20 tokens using Web3 to more advanced techniques such as utilizing Ledger for rapid transaction analysis. By the end of this workshop, you'll have the knowledge and tools to build a Uniswap V2 reserves model, enabling you to unlock valuable insights and make informed decisions in the financial landscape. So get ready to seize this opportunity, tap into the power of Credmark's model framework, and embark on a journey that will empower you to create impactful financial models. Let's make the most of this workshop together and discover the endless possibilities that lie ahead. Let's get the workshop started. Over to you, Kunlun.
All right. Thanks, Vineet. And thanks, MetricsDAO, for inviting us again. I'm very happy to present to you. I remember about 1 month ago, we were introducing to you the Credmark modeling framework. And not to forget that we have a free API key. Vineet, I don't know, you have the URL ready? That's access.credmark.com, right? Access.credmark.com. You can get your API key there. I think after you get the API key, you'll be wondering what can I do with it. So that's where I'm going to show you today. All right, let me start to share my screen. So maybe Vineet, you can stop your sharing first. All right, cool. Oh, I'm here. So I'm now right at the GitHub page from Credmark, and I'm in this repository called Credmark Models Notebook. And this is the third repository we'll be introducing to you. The first one is called Models PY, and also it's called Modeling Model Framework, pure PY. So all these three repositories are public and open source. So what is built on top? The foundation layer is the framework, and from the framework we build up the models, and that hosts our 280 models there. And from the models, we use model in the Jupyter Notebook, and that's another playground for doing explorer Web3 data, data analytics, and work around with various data and problems. So today, let's do a simple task. We do have a few subtasks, and let's get it going. So to start with Credmark modeling framework, it is nothing simpler than using the GitHub code space. So you can create your own. And right now I just have first to save some time to set up. I just have one that's on the run. So let me just open it, open the browser. So with a few minutes, you should have the development environment ready. Right? Okay, so I will just start from creating something new. Let's create a new, should be the notebook. Save it. Paste the lost connection. Let's just call workshop. Okay, cool. So it is about workshop. Get it going. So load the IPython kernel, clean up the space. Sure. So the first step is initialization. So let's create. From the initialization, import CMF, Credmark framework, Credmark CMF, Python, import create CMF, and let's import a few basic types for that. Types, import token, contract. Yes, so these are the few things that we can get started. So let's do create a context. The context is decides which chain we are going to work on and which block we are going to work on. So it's from the create CMF thing. So it returns two values. One is called context and another is called CMF model loader. So let's just worry about the context first. So create the CMF function takes default parameters. You don't need to enter anything. But let me do saying adding the parameter called show that will show what is the config. Takes a while to connect, right? And without a show, we just quietly create a context. So let's enable it. So the show parameter shows the configuration currently we are working on. So we are on the chain ID 1, which is the mainnet, and we didn't specify the block number, so it goes to the latest block as our node it is, and it connects to RPC node. So if you have your own RPC node, start here, add a parameter called chain to provider URL and adding the chain ID, and this where you can put your Alchemy, you can put your Infura chain RPC node address here. So right now I'm just using our framework's free ones, so that's available for all the users of CMF as long as you have an API key. So let's do that. So that's the context creation. So I take some time to explain, but you should get it going in just these 3 lines code. That server will give you a context. So let's first start looking at tokens. So may I ask audience that there is any token that you would like to, ERC20 token that you would like to explore? If not, I'll just choose my one from familiar with, which is WBTC, right? The webbed BTC. So we have some token symbols that load up. So I will just use the token symbol to load that up. So to give it name, so we call it BTC token. And that's it is markdown. So change it to Y code. So the BTC token is right at this address, and this address can be accessed from the Etherscan. Already open up. Go to the contract, recontract, and here we can visit the basic properties of this BTC token. So what is the name? What is the total supply? The decimal numbers, 8, which is different from the default 18, and symbol and owner balance of. So all these Web3 functions that we can call, and we can do the same here. So let's do get it. So I token decimal BTC token name. Let's just create a tuple, a Python tuple that's composed of all these values. And these values should be very close to what Etherscans give us. And Etherscan may sample the data less frequently. Maybe this was 5 minutes ago, this was 10 minutes ago, and ours should be very fresh. All right, so this is a simple one that use the CMF to visit a ERC20 token and gets its properties. So what underlies it is actually the Web3 calls. So for example, the total supply points to the functions. So we converted its attribute call to the underlying Web3 function call. So this is what we are doing in the Python object magic. So let's look at things that's beyond just the basic properties. So what could be the recent transaction with BTC? That's another thing, or another data we can explore with CMF. So to explore what has been the recent transaction, we need to look at the tokens ledger. The tokens. So if you are familiar with the events from ERC20 tokens, so every transaction on the token, ERC20 token, will record an event called transfer. So let's visit these tokens. Ledger on transfer. It's BTC token, ledger, events. So you can see that we use the object-oriented approach in Python, and we line up things in such a manner that we can access all these Web3 events and data in the and its objects, attributes, and the objects. So this is the ledger table. So let's print out what's in this ledger table. So these are the columns in this ledger table. So to query this, here, query this, ledger table. We'll do with a little bit of copy paste here. With this table as the Q. Q stands for query. So let's give it a data frame, df for data frame, Q query, Q.select. Okay. And we will pick up all the columns. Q.columns. And we'll say Q where. But it's like SQL. We wrap around the SQL syntax inside a Python function. So Q dot block number, that's between my current block number and let's say 1,000 blocks, right? Order by Q dot number, and also let's also order by the transaction log index. All right, and after that, we convert a query result to a data frame. Okay, and then let's display. The run error. See, got it. Yes. Order by should be separated by a comma instead of and. Sequenology. Okay, so there's not many transactions. Let me increase a bit of the okay. So let me do this. Okay. So let's see. Sort the block number descending order. Let's do it again. Let's limit to 1, and also increase our block number range. Query. So there's no data returned. That's strange. Okay. I think the order of the between should be the smaller should be in the front. All right. So let's get a bit more. For between function, smaller number should be placed in the front. Let's try to return everything. So within the last 1,000 blocks, there are 300, almost 400 transactions from that. So this is a way to explore the transaction for the ERC20 token. So after we have explored the token, let's move on to contract. So today's target of interest is a Uniswap contract. The reason why we're choosing a Uniswap v2 contract is that in Uniswap v2 pool, you're composed of 2 tokens. The 2 tokens will form a ratio by simply their amount. So if we have token 1 and token 0 and token 1, to get the price of token 1, that will be token 0's amount divided by token 1's amount. Right? So I will just write it down. Pool is composed of 2 tokens. 0 token. So price of 1, because that's per token 0 equals to token 0's amount divided by token 0. So that's a very simple math, which is the constant product, CFMM, CPMM for the AMM mechanism. So let's get a Uniswap v2 pool that's between the USDC and the WES. So let's call it USDC WES pool variable contract. There's markdown, so let me run it. This is it. let's explore what are the functions we can call. So instead of looking at either scan, so we have loaded up the ABI here. ABI, attribute, functions. After brief loading, you have result. So let's do a nice printing. Okay, let's do display. Oh, still shows is in a very long format. Okay. Let's do another Python magic. Use the DIR function. All right. So this will convert the attribute into a long list, and then the display will show it in a longer format instead of a wider format. So we can look at each of the functions clearly. So there are a function called token 0 that will give us the address of the token 0, and the token 1 similarly to get the address for token 1, and get reserve. So these function will give us the amount of token 0 and token 1 in this pool. All right. So these are the three functions. So let's get it. Yep.
There's a question from the audience. So they are asking if the loading of the ABI happens automatically.
Automatically.
Yeah. So the ABI do load automatically. We have a list of we have ABIs for a lot of contracts there. But just in case an ABI is not available with us, you can also provide your own ABI. But for most cases, for the more popular function, the more popular contracts and tokens, you'll find that the ABI is already there. So
yeah, exactly. Yes. All right. So if you want to inject your own ABI, so we have this ABI set ABI function, you can chain it with the contract. So for example, you want to say simple one, empty, and then you would say set loaded. This will make the will skip our automatic loading of the ABI from our own database, and then you will use this ABI instead. And then since we have an empty ABI, so then when you query, so basically USDC with pool ABI, and this object will retain you nothing, and of course the functions will be also nothing. So this is a way to in your own ABI. So this ABI can be a string or JSON, or can be a Python dictionary. So let's skip that, and we use our own loaded ABI. So just now before the question, which is a good question, I forgot to say, settle down three functions. Control, one, and get reserves. One more thing here. So if we know a function name, and we also need to know what takes it to call it, what is the input and what is output. So our ABI object also provides that. So USDC ABI functions 0. So this will give us the detail of the token 0 function. It's displayed. Keep the display. Display and then get reserves. Right. So all three functions here takes no input and output for token 0 and token 1 address, and get reserve will return three values, which is the amount of token 0, amount of token 1, and the third parameter is the timestamp that get updated. So the ABI object helps us to not only get the name, but also get details of the function. let's call this. So while we are calling, so let's give it a name. Call token one amount last. And since the token 0 and token 1 function only returns the address, so let's just call them token 0 and token 1 address. Let's get a printout of all these. 1 0 amount, token 1 amount. Okay. So all these are in the opt-in. Let's move on to what CMF can add on to the value, because all these are ordinary Web3 calls. CMF can add value on this because we have the token object. So let's start the token 0 address variable, which is the address, into the token object, and then getting the real token 0 and token 1 object. Token 1 address. Okay. Let's get the price of token 1. The token 1 is WES. So we are basically getting the WES price in terms of USDC. So 1 equals to, so amount, token 1 amount. And because all this amount is in the native uint 112 type, right? So let's scale it. Let's use the token object. It's function called scaled. Although it is a small thing, it's just getting the token zeros decimal numbers, and then divide the token 0 amount by 10 power the decimal. Right? But it just very convenient. We don't need to remember decimal numbers. Just call it with the scaled. And let's just print price 1. So the slow part is because of the node we're using. Maybe there are many people are trying our node. Okay, sometimes we just need to interact and then run again. Okay, so the token 1 price, which is WES price in terms of USDC, is 1,729 USDC per WES. So up to now, we have explored how this Uniswap v2 pool works. Let's wrap it up into a CMF model. So CMF model is a bundle of these Web3 calls and also the data, and we put them together like an algorithm or function that we are able to reuse. So write a CMF model. So I just so point. Import a few libraries, CMF model. So I need to change this to code. Okay, so for completeness, let's also include these types, although they have been included above. So types token So we use a decorator to declare some of the metadata of this model. So there are 4 metadata we need to find. The first one is called slug, the name of the model, which should be unique among our model universe. The second is called version, and then called description, and then a version that's uniquely identified the current version of this model. And let's say what is the most important is the input and output. Currently, the typings are just blocking. So these are the. So I mentioned about four. So actually, it should be 5. So let's just give a name of the this model. And you follow a simple naming convention. I call it a JIT because JIT means for just in time, right? Because we're just creating this model out of for to be used in this work. So let's all prefix it with a JIT. So then we give it name. This will be to pool, right? And then we can give a description that the price from initial to pool. Okay. So version sign 0. Then we give the input specify as a contract, and output we give a generic dictionary type of Python. So the input and output are good to be specified as a good type here because it helps us for data validation for the input and also for the output. Right? I'll have a very short, good example to show to you later. Let's have 1 minute. So let's finish this model first. Let's say it's V2 pool. Inherit from the model class, and you have default run function. And its input should be corresponding to the type of contract, and it should return a dictionary. And that will be the model definition. It's a Python class. It has a default run function that gets the input and then specified what is the output. Right? So let's copy some of the existing code that we have written on. So this have as the name some of the variable name so that it become more generic. So let's change the USDC West pool to just a pool. And then our pool object equals to input. So given a nice name, right? It's just a direct assignment. Just a nice name that's for the pool instead of an input. So let's move this line on. Right? And we are all good. And so remember that we say our price should be a dictionary. That will be price token 1. Let's also return price token 0. That will be price. So when you look at this model, of course, we have a few rough edges here. We say this part division. What if the token 1 amount is 0? Right? Then we have a division by 0 error. And so we don't consider that for now, but to build up a more robust model, we may need to take care of that. So we may say check if token 1 count is equal to 0, and we may say return so we return something called the overall idea here is that we try to apply good software engineering process and engineering practice for building a more robust model that can work across different data on chain and different scenarios. So for now, you may have other bugs, but let's just take the example as how we can improve the model against with various kind of data. So this is our model. So since it is a JIT model, that means just run it in this Jupyter notebook. I'll call the context. So remember, this context was created very beginning during initialization. Right? Context was created from the create CMF. Right? So context has a function called add model, and that's able to just add the class we have defined to the model list. It's like a model registration. So you will register. Otherwise, you may copy this content of the cell, save to a file, and that should be saved to somewhere in the model loader path. In this model loader path, where you can find multitudes of models there. Multitudes of models. You can see what is the pattern and what is the file organization. Save it there. Right? So we haven't run the model yet. So let's run the model. Run the model by its slug name. So it's called B2 pool. Hopefully, and just requires an input. Our input is our address of the pool here. Okay, we also face a very slow node, so let's run again. Okay, so it gets returned. So remember just now I want to show to you what is the advantage of using the contract as input instead of for something else. So it comes with a few advantages. So the first one is that let's just have a more formed contract address. And immediately we'll hit a validation error. So this address doesn't conform to the address format that the contract requires. And your model will never get to run. Right? So that's first example of validation. And another advantage, so this is on the defensive side. So the advantage of using the contract object is that we are able to use the JSON format. So the JSON format of the contract object is dictionary of address field and with the contract address. So we can pass this to the model, and it can also be run. So the model can be run against with any block number. So let's run block number minus 1000. Reorganize. Okay. So this was the price that's 1000 blocks early. So one, so here the two model runs takes about 5.1 seconds, and we can deduce that each model run takes about 2 seconds. And if we need to run for 1,000 blocks, 1,000 blocks, 2 seconds, 3 seconds, oh wow, that's almost 1 hour's time. So how can we scale that up? That would be my next question. Scale. It turns out that the V2 pool has this event. So let's continue to explore that with our ABI events. So it has this event called sync. And let's get what is the sync event. Sync event returns the reserve 0 and reserve 1. And the sync will run or will be emitted after every swap, after every burn or mint. That means after every withdraw or deposit by the LPs. The sync events tracks the reserve. So all we need to do is just to fetch the sync events from our database and build up for that 1,000 blocks. That means not every block will have an event, but we just need to fetch that number of events happening during the 1,000 blocks. And this is USDC West Pool is pretty busy. So in a very similar way, that's how we curate the transaction for the ERC20 token. We can also curate the ledger for the sync of this pool. So with USDC less events, sync is Q. Very similar pattern. Q select Q the columns. There Q block number. Ledger. Here. And number, string. And now I remember the smaller value should be in the front. I think I should correct this in our framework. 1,000 blocks, context block number. All right, let's do it in order. I Q number, comma, Q the block. Okay, so this is it. So let's do some of the clean. So we only need a few columns, not everything. Total block number and reserve 0 and reserve 1. So BP reserve 0. BP reserve 1. But we need, is there any question from the chat window? So, to sign number.
Somebody is asking to see your code path.
What?
Somebody is asking to see your code path.
Code path. Which code path?
Amir, can you please clarify what code path are you looking for? Meanwhile, Kunal, you can continue while we wait for Amir's answer.
Okay, can we see your code path? I guess if you want to get these workshop, is actually available. That's the notebook, the complete notebook that we have prepared. So you can get hold of that. VP reserve 0. So here is just pandas. Let's assign everything to integer. Here. Last line. And these are still full integers. So let's still apply that. Okay. 0 scale. Token 0 scaled are still effective here, and token 1 scaled are still effective here. So these will convert everything into floating numbers. Okay. And let's add another prices. Price. And so key stuff 1 divided by key. Okay. The other way around. That's our prices. Again, number is price. That's 1,000 blocks. The price is in 1,000 blocks. Okay, I think that's what I want to show for that. So the workshop files is actually available here in our models notebook repository, and you can find it under the folder called workshop, and this file called 2023 June 20 MetricsDAO. Happy to hear your feedback. Yeah, over to you, Benny.
Yeah. Thanks, Colin. All right. Can we switch back to the presentation, please, Bella? Yeah, thank you so much. All right. So as we conclude this workshop, I hope you feel equipped to build impactful models. We have covered a wide range of topics from the fundamentals to the advanced techniques, all within the framework provided by Credmark. Now it is time to take the next steps and continue your exploration. If you want to build some models, head over to our GitHub. You can find it at github.com/Credmark. If you just fork the repo and get started, build some models. And if you don't want to build some models, you want to just use the models. We have more than 180 models already there. You can head over to access.credmark.com to obtain a free API key, and you can start using our API and SDK to use these models. To further access additional resources, I encourage you to join our community on Discord. We are dedicated to supporting you every step of the way. So take advantage of our Discord community, our GitHub repositories, and explore the documentation. Yeah. So yeah, let's move on to questions. If you guys have any feel free to ask. Oh yeah, so Paul is asking if are there any limitations of the kind on the kind of Python libraries that can be used. So as this is a totally framework built on top of Python, there is no limitation on any kind of Python libraries that you can use. You can the popular libraries like NumPys, Pandas, all are inbuilt into the framework itself. As you Colin already showed in the workshop, when you're using the data frames, you're already using Pandas, and other libraries are all available there. So feel free to use any kind of libraries. And yep, this is the power of our model framework. Any more questions? If you have more questions, you can visit our Discord and ask questions there. We are all available. It's me, Kundan, and our whole team is there, all ready to answer our questions. And I think this concludes our workshop. Thank you, everyone.
Amazing. Thank you so much, Vinita and Kulun, for the amazing workshop. And thank you, everyone, for attending today. Do reach out to them if you have any further questions sometime in the future. And everyone, have a good day ahead. Bye bye.
Thank you. Bye.